And the second problem, we're just trying to work with the area of a rectangular piece of land, and they've drawn the picture for us and even labeled it with X's, so there's not a whole lot to do in this problem. We're trying to maximize area. We can see that from the problem. It asks for the largest area, and so that means I want a function that describes area. Because this is a rectangle, and they've already labeled it, I know that the area of this rectangle in the picture is x times 6,000 minus 2x. So I want to maximize this, which I can, because again, this as a parabola, as a graph, is going to be a parabola that's concave down. So I'll have area as my outputs, and x is the distance away from the river the fence goes, as my input. So I'm trying to find the value of x that maximizes the area. So again, that's going to be coming from my vertex. So I can do that the same way. I could multiply out my formula and use minus b over 2a, or I could just figure out what these intercepts are. This one obviously is at 0. First factor is 0 when x is 0. The second factor is 0 when x is 3,000. And so the 2x intercepts are 0, 0, and 3,000, 0, which means that because of the symmetry of the parabola, the x-coordinate of the parabola is at 1,500. So the value of x that gives me the biggest rectangle is 1,500, and then this length measurement is just 6,000 minus twice x, so in other words 3,000. And I can stop and check for a second that I really have used the right amount of fence. Altogether that uses 6,000 meters of fence. And the area, in that case, A of 1,500 is 45, and then like 5 zeros, whatever that is. So these are the slides written out, and you can see it says the same. The last problem is not really a word problem. It's really more of a fitting a parabola to data more than anything else. We're going to have a bridge described to us, and the key here is to draw this on a coordinate axis. And there are a lot of decisions you can make about how to do that, but none of them will lead to the wrong answer, so it doesn't really make any difference. Just pick something. So I'm going to lay down my x and y axis and then draw my suspension bridge on top of it. It says the towers are 70 meters off the road, and the parabola touches the road in the middle. So I expect the picture is going to look something like that. This point is 0, 70. There's a point over here that also has a y-coordinate of 70, but its x-coordinate is all the way over. They tell us that the towers are 400 meters apart, so 400 meters over, I also am at height 70. And then because of symmetry, I know that the vertex of the parabola will be halfway between the two. So the x-coordinate of the vertex will be 200, and we chose to draw it so that it actually touched the x-axis, so the y-coordinate is 0. So really, if I just draw the information that's given in terms of coordinates, then it's easy to find the equation of the parabola. I guess I'll use F. I know that f of x is going to be some number times x minus 200 squared plus 0. This is that vertex form of my equation of parabola. Let me write it over here so it's a little clearer. So f of x is something, some number, times x minus 200 squared. That does fit the vertex. If I put 200 in for x, I get 0 for y, so that works out. But it doesn't do anything for these other 2 points. So this point, we'll pick this one since it involves 0, it'll be easier. This point tells us that f of 0 is equal to 70, but our equation tells us that f of 0 ought to be a times negative 200 squared. So in order for those two things to both be true, it will mean that 70 must be equal to a times 200 squared. So that's 40,000 times a. And this is going to mean that a is 7 over 4,000. So the equation of the parabola that I wrote here, it will be correct if I use, instead of the letter a here, I use 7 over 4,000. So let's see what that looks like. Okay, so let's see how we get a new page here. So if f of x is 7 over 4,000 times x minus 200 squared, the question was, what is this? What is the height of the cable when x is 100 meters from the center? So 100 meters from the center, remember the way we drew this, meters from the center would either be here at 300 or here at 100, and because of the symmetry of the parabola, I really expect the height of the cable in both cases to be equal. So let me calculate this for 100. So putting 100 in for x gives me 7 times 100 squared, that's 70,000 over 4,000, which a lot of those thousands go away. So 70 over 4 is 17.5 meters. And if you do the same calculation using 300, you would also find 17.5 meters. So the cable is only 17.5 meters off the ground at the 500 meter mark, goes up to 70 meters off the ground when it goes to 0. So that's it. Oh, well, shoot. I typed it out differently than I was saying to do it.